Okay, so let me introduce you to this course titled Design for Internet of Things. Essentially in this course what we will do is, so when you say the word design, what comes to my mind is that design is always designed for a specific requirement, right. You are doing it for a particular purpose, you are doing it for meeting a certain requirement, which essentially means there can be multiple choices in trying to provide a design, right. There can be design choices. So the idea of design for Internet of Things means that you are given several things available around you. It could be in terms of different sensing modalities, it could be in terms of microcontrollers, it could be in terms of communication devices and so on and so forth. How will you choose the right one, right. So that means design essentially means choice. How do you pick something, which means it has to be just not based on cost, not just based on some flimsy reason, but indeed it should be optimized for that requirement, right. So that is an important thing. How do you bring this thing about? Let us take an example of one sensing modality, right. Let us take temperature as a, or heat and temperature are sort of interchangeably used, right. So you can sense heat with a temperature sensor, and you may want to sense heat itself. Where is temperature required? Where do you actually need to measure temperature? Is it if you are trying to read the skin temperature, or are you trying to read the core body temperature of the body of the human, or you just want to sense heat around you, right. So take one sensing modality, it could be temperature, it could be heat, which I will sort of interchangeably use, and then show you what kind of sensors are available in this space, what is the physics behind these sensors, and how do you choose a particular sensor for a given requirement, and complete a nice story around introducing you introducing you to the important aspect of choice of trying to get to a design or choice of sensors getting to a particular design. Okay, so that is one thing. The second thing is, if you really have to build an embedded system, just take a high level view of an embedded system. You have the heart of the embedded system, which is a controller, right, a microcontroller. It could be a microprocessor. It's nowadays microprocessor is not being used, mostly microcontrollers which are used, which have lot of embedded systems into it, into the controller itself. For example, the communication radio, low power radio is part of already the controller. So you have sensing which is possible through different ports of a microcontroller. It could be through general purpose input output, it could be with analog to digital conversion ports, and you have computing which is possible within the processor itself, because there is a CPU associated, and then there is communication which is also part of the system. So if you want to build an embedded system where the heart of the system indeed is the microcontroller, there are other very important, extremely important parts of an embedded system which forms an IoT device, right. One section which comes to my mind and which has perhaps created so much of discussion and so many companies, chip companies trying to make them, is related to power supply. Okay, so that is a very critical part of your embedded system, of your embedded IoT device that you want to build. Why? Because your embedded device could be powered through a battery, or it could be powered through non-battery based systems like storage devices like supercapacitors. And where does the energy come to supercapacitors? It could be harvested from the ambient, it could be coming from solar, it could be coming from radio frequency, it could be coming from temperature differentials, it could be coming from linear motion, right. All these are other ways of generating energy. It could be coming from aeroelastic flutter, right. So all these forms of energy which you use, convert it into electricity, into electrical energy, and store it into a capacitor in the form of a charge, and use that to drive the embedded system. That is one way. The other way is a battery, right. You could be using a rechargeable battery in one case, it could be use and throw battery in the other case. So, you need charging circuits if it is a rechargeable battery and so on, right. And then you need stable power for applications. In other words, you want to improve the lifetime of the embedded system, which means it should be ultra low power design. That means there should be no power dissipating components, your number of power dissipating components should be minimized, and one of the important things indeed is the regulator, okay. The power supply regulator, the regulator itself should not be taking a lot of quiescent, it should not be drawing a lot of current. In other words, the quiescent current should be in micro and nano amperes, if not even lower, right. So, so one section that we have to really worry about is power supply, and within the power supply we should be worrying about sources of power, and we should also be worried about conditioning the power, ensuring that stable power is available under different conditions. That is one thing. Stable power also means another things. Different parts of your IoT embedded device require different voltages, rail voltages. In some case you can operate the microcontroller from 1.3 to 3.3, but the display system requires, let us say, higher voltage. In some situations the communication radio might require a different voltage, may have a different voltage requirement, which means step up and step down will have to be designed part of it. So, you will have to encounter buck converters, you will have to look at boost converters, and you will also have to look at ensuring that these are ultra low power dissipating components themselves, which means we will spend significant amount of time trying to understand linear regulators, which are nowadays most IoT embedded devices actually use them, and they are called LDOs, low dropout regulators. So, LDO, boost converters and buck converters actually form the section related to the power supply. This is one part, one block of the embedded system, the IoT system that we want to build. The second block also very important is the communication block, right. How do you want to do this communication? You want to do ultra low power communication to a nearest gateway of whatever you have sensed, because when you talk about IoT you are actually talking of several billions of devices, and each of these billions of devices have to communicate. They have to sense, they have to gather data, they have to process to some extent this data, and they have to communicate this data. What are the ways, what are the protocols, what are the kind of communications which are possible, which are ultra low power, which will continue to keep the battery going for many years. See, today if you talk about a battery driven device, an IoT device, you are talking of lifetimes anything greater than 1 decade. It does not make sense to design something which does not survive for 10 years, because cost of replacement of battery is so high that if you put one battery, either if you say a non rechargeable battery, that battery should last for 10 years. So, huge shelf life and ultra low power consumption by the embedded IoT embedded device itself, which will ultimately make your device survive for more than 10 years, which means you must look at the communication as an important, because the data that you gather will have to be communicated. Communication has to be ultra low cost. How can you do that? Well, one option is whoever is asking for data should also bear the burden of providing power to the device such that communication is possible, and one such mechanism indeed is the RFID. So, we have to spend time on RFID protocol. Then you may want to understand other ultra low power protocols like standards, for instance ultra low power standards like ZigBee, which is also called the IEEE 802.15.4, is a very important aspect of an IoT device, and we have to understand that protocol, that standard very well. Then you have Bluetooth low energy, which is now the latest one being 5.0 version. You need to understand how BLE 5.0 works and how you can integrate BLE 5.0 into several of these IoT sensing devices. So, there will be a significant portion of communication protocol which you have to put in communication technology, let me call it communication technology, that you will have to worry about. Then associated with the communication technology is the communication protocol of interest, right. There are two protocols that come to our mind in the IoT space. One of them will be based on publish subscribe, and the other paradigm which is for communication would involve the RESTful architecture. So, there should be sufficient time being spent both on the RESTful paradigm as well as the publish subscribe paradigm communication models, call it communication paradigm models, on which protocols are actually built. So, we will spend time on publish subscribe communication model paradigm called MQTT, message queue telemetry transfer, and we will also try and spend sufficient amount of time on the RESTful architecture based CoAP, okay, constrained application protocol, right. We will spend time on both of them and try and see how they are amenable for ultra low power yet provide reliable sensing and communication. So, that is another important thing which we will spend a significant amount of time. Finally, what we will also do is we will take examples, different examples from we will take examples. So, another finally what we will also do is we will take case studies. We will look at we will see how to build this IoT device, all of it put together, whatever we have learned till now we should be able to put it into practice. So, let us take one case of an energy meter. Let us build this energy meter and let us see let us look at all the aspects of what we are discussing in an IoT device such as an energy meter. Let us also look at other simple applications. Let us say you want to track something, some device, and let us see how we can use BLE, Bluetooth Low Energy, for tracking different application. Let us build another application around that. We will also have to look at the following problem, right. Suppose you gather data from several sensors onto a gateway device. How will this gateway communicate over a wide area, right. So, we must look at low power wide area network protocols, communication protocols, and to my mind there are three important protocols that require attention. One is called LoRa, okay, from the LoRa Alliance. The second and third actually come from the cellular world. The second one is narrowband IoT, and the third one is LTE-M. Both of them come from the cellular world. Of course, there is a proprietary standard which we cannot forget, and that comes from that is called the Sigfox. So, we will have to look at LoRa, Sigfox, NB-IoT as well as LTE-M protocols, which broadly all these protocols will form will fall under low power wide area network protocols under the in the IoT space. So, let us spend significant time in understanding those protocols as well, right. So, in summary, let us look at design for Internet of Things by taking a step back and saying what are the design choices available with us. At every stage there is a choice of microcontroller, choice of communication model, choice of the communication protocol that we want to do, choice of switching between a linear power supply and a switched power supply. All these choices are available in front of us. Let us understand each and every part of it and see how we can use that particular component, particular method that we want to adapt in order to create an IoT device. Thank you very much.